introduce is ICR National Professor at ICR National Institute of Agriculture, Economics and Policy Research. That is this institute. Earlier, he has worked at ICRISAT also, as well as Institute of Development Studies, Jaipur, as a director. And his only passion is research. He has made notable contributions in agricultural economics and policy research, and his contributions mainly focus on interrelationship among high value agriculture, agriculture growth, rural poverty, market linkages and value chains in smallholder production systems, impact of information on returns from farming, institutional and policy requirement for accelerating adoption of technologies. And the one which he's going to cover today, along with Dr. Javeri, is impact of information on, climate, impact of climate change on agriculture. So he has published more than 100 research papers in national and international journals with very high impact factors, along with number of books, policy papers, working papers, discussion papers. He has got various recognition awards for his notable contributions in social science. He is also a fellow of NAS, as well as he has been conferred recognition award by NAS and recipient of very prestigious national award, that is Rafi Ahmed Kidwai Award of ICR in 2016 itself, and many best paper awards from professional societies. Not only that, he is member of editorial board of many national and international journals and committees of central and state governments. So with that, sir, I would just like to invite you to give brief on this lecture, and then I will introduce Dr. Javeri also. So she is assistant professor with Christ University now. Earlier, she worked under mentorship of Dr. Pratap Singh Bithal, and they have produced this beautiful publication, which she has just shared with me also. I will be sharing with participants for reading. She has her PhD from Jamia Millia Islamia, and her research areas are economics, environmental and resource economics, development policies. And like her major research is basically applying improved analytical models to study how empirical findings can be used to derive long-term strategic implications to inform theory as well as guide decision makers in the area of public policy and its management. So I'm sure like this is going to be very useful lecture for all of us. So sir, please, the floor is yours. You may introduce the topic and like what we are going to learn in this.
Thank you, Dr. Jain, for inviting me and Dr. Javeria Hajrana for this interaction with the participants of this winter school. And I'm happy by listening that more than 900 applications were there for this program. So this shows that how people they require, the requirements of the people for analytical techniques. So their interest in those kind of things. Well, friends, nowadays it is the, you can say, the age of analytical techniques. And what you require for research, yes, one is the understanding of the concepts of the problem which you are going to address, what questions you are going to address, frame some questions and hypotheses around the problem, and then think of the methodology which you are going to choose to address all those type of questions. There are a number of methodologies or analytical tools that you can rely on to solve any problem. But each of these methodology or the techniques, they have all their own limitations, okay, own advantages. Some techniques, they might be quite data intensive, another might be quite demanding of the mathematics or the statistics, which may not be, all of us are not well versed. But one thing, of course, I would like to say that if you are interested, you can learn at any stage, at any time in your life. I am getting old, but still I keep myself abreast with the new developments, particularly in the methodological aspects. And how I learn is I learn from you people, the young people, young mind. I just keep on probing them, instigating them. Okay, what will be? And this is what I have done, particularly with the people who have worked with me, especially Dr. Javeria Hajrana. Okay, I just give, okay, Javeria, we will do like this, then she will come with some idea. So this is the technique that we can use. And for that, what you have to do, you have to read a lot of literature related to those issues, concepts, and the technologies. And only then you can build upon the technologies. Now, this is an opportunity for you people to learn the new techniques and interact with the people who know these techniques. So until unless you do that, just by attending the technical program for getting a certificate is not going to serve any purpose in your life. Until unless you learn those techniques, those methods, and all that kind of thing. What I observe, I am just also an editor of our agricultural economics research review. So what I observe, the papers that we get for publication, they are, I say that they rarely use any econometric techniques. Sometimes most of the papers, they are just a simple comparison of the means, and they don't even bother to look for, the standard deviation and all those kind of things, the traditional kind of methods that we are using, still we are using in this kind of things. So, and now, as I said, that the science has advanced, economics has advanced, mathematics has advanced, statistics has advanced a lot. And a number of, new techniques to address any kind of scientific problem or the social problem or economic problem. There are a number of techniques that you can use it. Now today, Dr. Javeria, she will be teaching you the method, which is, you say, of course, the people have been using it for some time, but it has not been applied much to agricultural problem. That is, endogenous switching regression techniques. And it's a very powerful technique, I realized, right? It can be used, for comparing the yields with and without kind of situation. There are adopters, there are non-adopters, and then of course the risk. Climate poses a great risk to the agricultural sector, to the food security, national security, and otherwise what I say that to the humanity. Now there are a lot of concerns around climate change, how it will unfold in the future. The IPCC reports, recent reports say that if we are not able to control, the temperature, but the rise of temperature below 2 degrees by end of this century, its effects on agriculture and other economic sectors, they will be quite disastrous. Now, one thing that climate change, it is changing. It is changing differently in different countries. It is changing when climate is changing. Climate change means it's a gradual kind of change. But now what is happening, that extreme changes in climate. Extreme changes when I say the droughts, the floods, heat waves, cold waves. Now they have become more frequent in the past, and they are likely to become even more frequent in the times to come. Now these, different types of this kind of shocks, they have a differential impact on different economic sectors. In different regions, they have different economic sector. For example, if you go through the global literature, you will find that agriculture is the most affected by climate change or climatic shock compared to other economic sectors. And if you compare agriculture, its impact on agriculture in developing and developed countries, the developing countries are more vulnerable to climate change than the developed countries. One, of course, most of the developing countries, they are located in the warmer regions. And another is they lack institutions, infrastructure, technology, resources for risk management. Now, the question then arises how to manage the risk. There are number of techniques, number of methods, number of measures to manage the risk. Some of them, of course, farmers have been using since ages, and some of them are the new ones. Okay. Now, but which one, whether the traditional techniques, they are really efficient at improving, say, agricultural productivity as well as reducing the risk, or is it that modern technologies, when I say that, maybe adoption of crop insurance, use of crop insurance, is it more effective? Or now the people say the climate smart agricultural practices, are they more effective than the traditional ones? Or is it the combination of these technologies which is more effective? So these are the questions that one has to address. But particularly what happens that in developing countries, as I say, that with lack resources for risk management, mostly the farmers are small landholders, and they rely mostly on the traditional methods. What kind of traditional method they could be? They might be just, integrating, say, animal husbandry in their production systems, or they may be diversifying to more than one crop or to the high value crops that generate higher returns, but still they are very risky. Or some other techniques, risk mitigating or risk coping mechanisms. Risk coping mechanism, when I say that once the an event has happened, then what farmers do? So that will they go for some kind of say remittances from other family members, or they will go for employment outside agriculture, or they will migrate, or they will borrow. So all this kind of thing, risk coping kind of things, technologies. Now, once we have looked into that, there are two issues, be it any kind of technology or risk management. One is a farmer will adopt a technology or any risk management measure if he feels that he will be better off with its adoption. Okay. Now, another questions, and in such kind of situation, what kind of techniques we can use if he utilizes only, say, one technology? Say, for example, crop insurance. Will the farmer adopt crop insurance? Now, what kind of method, statistical or economic technique we can utilize to see the effect of crop insurance on, say, risk management or improvement of the agricultural productivity? Now, when there are more than one technology, what happens? He will compare, how the net benefits of these alternatives. Now, if you find that, okay, if I am better off with the adoption of crop insurance, but at the same time, say, I am also better off with crop and adoption of crop insurance rather than diversifying my agriculture towards, say, high value crops, or going for long-term kind of investment in irrigation and all those kind of things. Now, this is what Dr. Javeria Hajrana will be teaching you. That is, kind of, first that endogenous switching regression model for only one techniques, and then she will be taking about how you can use the multinomial and endogenous switching regression models. So with this, I hand over to Dr. Javeria. Dr. Javeria.
Yes, sir. So good afternoon to everybody, and thank you. I thank Dr. Bertel for giving a very good opening against which this technique can be conceptualized. So I will start by sharing my screen. So the methodology that I will be covering today it's termed as the multinomial endogenous switching regression model. This is a very interesting technique, and it's a very important factor about this technique is that it is very well suited to certain questions and to certain situations. I have divided just for ease of understanding and
Javeria, just make it in slideshow, please.
Okay. So just to highlight exactly what this technique does, how it should be interpreted, and what kind of data sets it's really compatible with. I have divided this presentation and this talk today in 3 sections. The first is basically in 3 sections and more broadly 2. The first is, where does this start from? What is the background of the multinomial endogenous switching regression model? And what are the drawbacks of other kind of methodologies that it fulfills? And what is the kind of situation and data that it is compatible with? And then I follow this up with an application showing how it is actually applied and how its results are basically interpreted. So I start a good starting point for understanding the multinomial switching regression model is to see where it builds on, to what kind of factors it builds on. So we have the whole impact evaluation literature is certainly seeking to understand the effect of certain programs on those who adopt those programs, or in other words, those who are treated with those programs. And the impact evaluation literature basically, it would divide the population into those who are treated with a certain program against those who are not treated, and with the broader objective of the question of what would the outcome be if a certain individual or a household adopted this treatment, whatever the treatment might be, compared to those who did not adopt. And the whole beauty of this impact evaluation literature comes from being able to answer this simple question: what is the impact of the treatment? However, there are certain situations where we are not able to apply this impact evaluation literature due to some problems, and I have enumerated some of those problems over here. The first problem is that sometimes it is essential to understand what is the treatment effect of a certain program or adoption strategy, but the data that we have with us is observational. We basically do not have observations of those who are treated and the situation where they might not be treated. We do not have 2 groups which are totally comparable in every way, except the fact that some of them receive the treatment. So the first important point is that in many situations, the data is observational. So that's a limitation which literally stops proceeding with any kind of impact evaluation. The second is that you can have some variables which influence the treatment as well as the outcome variable. So you can have confounding influence on the treatment as well as the variable which we are observing, in other words, which is our dependent variable. The third important factor, and this is something which has been pointed out in a 1998 study by Wu and Babok, they say that at times people do not adopt a single kind of treatment. It is possible that they adopt multiple treatments. And if you have households or individuals who are adopting multiple treatments, then these treatments are simultaneously not additive. And this is really a very statistical point, because they say that until and unless the approach itself accounts for simultaneous adoption, you're not going to come out with treatment effects that are representative, because they are not additive. You have to have groups where you're accounting for the factor that some of the people are simultaneously adopting more than one treatment. So this is a very interesting point, and it needs to be incorporated while we proceed with looking at treatment effect or impact evaluation. The next point is, and this is a very important point, it says that it is possible that individuals who adopt a certain treatment are really self-selected. They might be having some unobservational, some inherent qualities which provoke them to adopt the treatment effect. So the model or the approach needs to account for the fact that these groups or these individuals are self-selected. The second is the approach itself, and this really is a point that has gained a lot of prominence in recent times, is that when we begin with impact evaluation, sometimes the dependent variable itself a complete picture. So the model must be compatible to some kind of extension. For example, if we are looking at income of farming households, they might not often give a complete picture. It is also to incorporate with it some aspects of risk, variance, income stability. So the approach must be compatible with some kind of extension. So these are some of the highlights where against which the multinomial endogenous switching regression can prove to be very effective. So since treatment effects are generally estimated in controlled environments, but you do not really have access to those kind of data sets often, we end up with a problem which is a selection problem, or we end up with a problem which is a missing data problem. And not being able to answer this counterfactual question just because we do not have observations of those who are treated and those who are not treated has led to a lot of prominence in risk. Though this methodology has been there for quite some time, but it has put it has given a lot of prominence to these kind of treatment effects, and endogenous switching regression is one of those. Now, just before I start commenting on the multinomial endogenous switching regression, I will mention a few points about the endogenous switching regression. The only difference between these is that the endogenous switching regression model is compatible with two categories. One is treated and one is not treated. So what it does basically is that it partitions individuals into two classes based on the treatment. And this treatment can essentially be what the researcher is looking at. For example, if you're looking at the adoption of certain climate smart technologies, then the treatment would be the adoption of that technology. And you can basically have two groups of those who did adopt and those who did not adopt. And another highlight of this model is that it is used to study continuous dependent variables. So it is not really necessary to go for a binary dependent variable. You can adapt this methodology to variables which are continuous. And this really makes this model very much flexible. Technically speaking, the endogenous switching regression model really is a variant of the instrument variable approach, because what it does is that it bifurcates the whole process of looking at treatment into two steps. And first, it basically in the first step, and I'll comment more about how it is estimated later, but just as a starting point, it bifurcates the whole estimation process into two stages. In the first, you have a switching equation, which basically sorts individuals over their different states. The states over here referring to the fact of whether they did adopt or they did not adopt a certain treatment. And from here, it controls for the selection bias. And moving into the next stage, it incorporates the selection bias. So what happens is that we are able to see the impact of adopting the treatment, but it is controlling for the fact that there can be observed or unobserved factors which are influencing the adoption itself. There are some examples of where this model has been used. So there is a study right back in 1978 by Lee. And this study, very interestingly, it looks at unions, so labor unions. So it's seeing that whether laborers are members of certain of labor unions, does that impact their wage rate or not? And doing so, it's using the endogenous switching regression model. So they have two categories. Are these laborers members of unions or not? And if they are, does that in any way impact their wage rate? There's another study in 83, and this study is basically using data to see what happens when workers are working in public or private sector. So does this kind of being a part of the public or private sector, does that actually impact their wage? Is there a wage differential or not? More recently, there are many studies that are trying to use this methodology in the context of agriculture. And the reason being that a lot of the times, the data that we have for agriculture households is observational data. It is sample data. We do not have information about the same household moving into a treatment and at a certain point of time, and also data about that household not being treated. So we do not have those kind of that information with us. And in such a case, the endogenous switching regression is really handy because it allows us to estimate treatment with observed data, with sample data. So some of the questions which have been dealt with and which are very interesting in the context of agriculture, I have put it on the screen here. I think I did something. Just a minute. I think I accidentally did something to the screen. So some of these questions, the context of agriculture, I have enumerated on the screen. The first would be insurance. So there is a lot of insurance is a very interesting subject in the context of agriculture. For example, if households who actually do go for insurance, do they see any benefits in terms of productivity or in terms of their household income, agriculture income? Another important question is credit. What about credit? Do households who take credit, do they actually see a positive impact of that credit on their productivity, on their production, or even on their income? What does the source of credit matter? For example, credit can be availed from formal sources, from informal sources. So is the benefit from availing credit from these different sources, does that differ? Households which take credit from formal sources, do they see better impact on their income compared to those who avail it from informal sources? The third question which I have put on the screen is, what about adoption of technology? So do multiple technology adoption decisions such as agronomic practices, the rotation, intercropping, minimum tillage, do these techniques, do these adaptation strategies confer benefits to farming households? So these are some of the questions which can be addressed with the help of endogenous switching regression model. Now we have discussed what I was trying to scroll, I accidentally again did something to the screen. I'm sharing again. Okay, so we have discussed that there can be different categories and of those who are treated and those who are not treated, but there can be a slightly more complex case. It is possible that sometimes the treatment is available in terms of categories and not just two. For example, a farmer can have the option to avail technical advice, and this technical advice can be of different kinds. So you can have farmers who do not avail technical advice, and you can also have categories of farmers who avail technical advice on breeding, feeding, or any other type. So based on this, now we cannot look at the endogenous switching regression because that is based on two exclusive categories, adoption compared to non-adoption. And now we would be moving on to the multinomial endogenous switching regression, because this technique is compatible with multiple categories. So you can basically extend the endogenous switching regression to many categories, multiple categories, and then you will, come up with the multinomial endogenous switching regression. So on this screen is a very simple example of how the categories are formed, and I'll talk a little bit more about it in the latest slides, but this is just to give an overview of how this works out. So the first row shows no advice, and following are the combinations of technical advice that can be formed with this data. So you have breeding, feeding, and others exclusively, and moving on, then you have combination, and these can be, for ease of interpretation, be referred to as portfolios. So you have got three exclusive categories, and then you have the portfolios. So you can have farming households which are adopting, any one of these, and they would be falling into these different rows based on what they are adopting. And while this table basically gives an overview of whether or not they're adopting, the second one is an example of how the observations would look. So hypothetically speaking, if we had a sample of some 1,000 households, 32,000 or 32,500 or something like that, then they would be bifurcated into these separate categories. And based on that, we can observe who is adopting a single strategy or more than a single strategy. And this is how the data would then be bifurcated into different subsamples. An advantage of the multinomial endogenous switching regression over other instrumental variable techniques is that when you estimate this model, the first step would be giving you the impact on the treatment effect, but moving on to the dependent variable, you would be able to estimate as many simultaneous equations as the number of categories. And this is really a very important point, because then you can see the impact of this treatment on each and every one of these categories. So if you have 8 categories, and the hypothetical example on the screen basically shows 8 categories. So if you have 8 categories, you would then be having estimates for all 8 equations, and you would be able to study the impact of every included variable on the dependent variable specific to that group. In the following slides, I basically highlight how the equations of the MESR, the multinomial endogenous switching regression, look. And I start with the selection equation. So the first equation is the selection equation. And this is the step from where we actually generate the selection bias corrected terms so that we can include them later. Just for the sake of understanding, I have adopted a problem, and I will talk a little bit about it later when I show the application, where you have different farm households, and they are faced with the choice of risk management tools. And the first step is to understand that farmers basically start from a point where they are trying to maximize their income. And the way they do so is by comparing the expected income that they would receive when they adopt one or more of these strategies. So we start by observing a latent variable, and it is given in equation 1. And in the first term, the dependent variable, basically a latent variable, and it is expressed as a function of some observable factors. And these observable factors are basically household characteristics, farm characteristics. And then you have a second term, and this captures the impact of all those factors which cannot be observed by the researcher. So this is our idiosyncratic term. A farmer starts by choosing a portfolio where he thinks he can get the maximum expected returns. We cannot observe the returns, but what we can observe is the choice of the risk management strategy that the farming household does choose. And equation 2 captures that. So this equation is expressed by incorporating every risk management tool that is available to the farmer. And that is why we have Y ranging all the way from 1 to N. And N is the last risk management strategy. So hypothetically speaking, if we have 8 separate categories, N would be 8, and the farmer would adopt it if and only if he expects that the returns he gets would be greater for this strategy compared to any other. And then he would choose such a measure. So basically, he's starting off with his expected returns, since we cannot, and that's our latent variable. And since we cannot observe that, we start by observing what choice he's actually making. A very important factor building from this equation, equation 2, is that we assume the error term in the latent variable equation to be identically and independently Gumbel distributed. So there's an important limitation of this assumption. And just before I come to that limitation, we have this equation, and over here, this is expressed as a multinomial logic function. This is precisely what is estimated in the first step. The base category is always non-adoption, so that we can actually compare the benefits of any strategy against those who did not adopt. So the main limitation of this assumption is that we are considering that the probabilities from choosing any alternate portfolio are independent of the others. So, and this is really a very much a very limiting assumption, because adoption is never an independent process. Adoption is always something which is compared to whatever other strategies are available to the farmers. And in order to account for this, this is something which was pointed out in this 98 study. And the way to do it would be incorporating, extending this equation basically to incorporate some correction terms. And that is that is what is done a lot to basically take account of this factor that adoption is not something which is an individual decision. It is impacted by other portfolios available. So, and this would be incorporated, this limitation would be incorporated in the following equation. But moving on to the second stage, we now have our outcome equation. In the outcome equation, our dependent variable is now changed. In the first step, it was the choice of adoption or the choice of the treatment. Now we have the variable on which we want to see the impact. For writing these equations, I have taken the dependent variable to be farm income. It can be any other variable on which we want to see the impact. For now, for the purpose of this equation, I've considered it to be income. So we see the impact of different risk management strategies on farm income. And again, the outcome equation is basically replicated for each and every risk management strategy. So it starts all the way from 1 and ranges till n. N for this example is 8. So this last equation would be pertaining to the 8th strategy. And this is really one of the benefits of the MESR. You get an equation for every strategy, even for the non-adopters. So even the group that is non-adopting, you are able to see the impact of all the included variables on the samples included in that category. So I over here in this equation represents the outcome, which is basically farm income for a certain farming household. X is again a vector of observed variables. So these can be farm characteristics, institutional factors, so on and so forth. And we have this error term over here. But this equation is, before estimating, it needs to be modified slightly just to incorporate the selectivity terms. And we do that following Bergenon et al. And so this is the extension of that equation. We now have an added term over here where sigma is the covariance between the two error terms, meaning the error term in the outcome equation and the selection equation. And we have lambda, which is the inverse Mills ratio. And in this multinomial setting, the number of selection equation generated is 1 for each alternate risk management strategy. And we also account for heteroscedasticity by generally bootstrapping them. Now, while using the multinomial endogenous switching regression, essentially we have 3 sets of results, and I have already covered 2 of them. The first is the results from the selection stage, which is basically a multinomial, which is the logic model. And then we have results from the second stage, which is basically the OLS along with the selectivity terms. So it's basically an OLS regression, but we have incorporated the selectivity terms. And the third, the screen now is basically showing the third set of results, and this is the average treatment effect. And this really is the most important part of this whole methodology or approach, because this is the state that allows us to say what exactly is the benefit that households saw just because they adopted this strategy. In simple words, it is asking the question, what would these households get in terms of income had they not adopted the strategy? So what is the benefit of adopting a certain treatment? And the way that this is done is basically using the coefficient estimates of the MESR model to obtain the expected income for households had they not adopted. And that's why it says adopters with actual adoption. So this is the equation which basically gives us what these households get when they adopt. And this is the actual case, because the data is showing us those households which adopted a certain treatment or a certain risk management tool. And this is followed by generating a counterfactual. And this counterfactual is generated by using the estimates of the MESR. And it is asking what would have happened had these households not adopted the treatment. So this equation here is the essence, and it is whatever we had been at the cover till now. It's building upon on those first and second stage estimates to basically ask the question, what would be the returns to these households had they not adopted the treatment? So this is a counterfactual equation. Had households not adopted the treatment that they did adopt, what then would be the returns? And once we take the difference between the actual and the counterfactual case, we derive the treatment effects, which show what is the percentage increase that households saw just because they adopted a certain strategy. So this is the last slide of how the MESR equations look right before we go into the application. I do have some slides where we show how it is done and how do you interpret the results and what do the results look like. So the slides are basically adapted from a very recent paper where we use the MESR to look at risk management strategy, and it builds upon the points that climate change is something which is really very much apparent in present times, and developing countries are really very much vulnerable to it because of the geographical location, also because they often do not have the tools required to mitigate risk. And they also are, and the farming households specifically are very badly impacted. They often lack all these institutional mechanisms, sophisticated institutional mechanisms, which would allow them to reduce the impact of these risks. However, households which do expect certain, climate, the negative impact of climate, do not passively tolerate these risks. They utilize a single or combination of certain traditional measures, which would help them to cope or be prepared against the impact of any climate risk. And these traditional measures are those autonomous adaptations which take place on the field and include diversification, irrigation, livestock holding, and non-farm income, and many other strategies. An important point, however, is that risk mitigation or risk management is really not a costless process. When farming households engage in these kind of strategies, they basically divert their income, their limited resources from other productive activities towards risk mitigation. And just because of that, they would always compare the expected benefits from adoption and against a scenario where they do not adopt or choose an alternate strategy. So building on these points, we highlight some areas in the literature where these factors have not been looked at. And these are the points which really allow us to adapt the multinomial endogenous switching regression to this issue. And I have already covered them when saying that what possible limitations can this methodology cover. So this often data is observational. So again, to address this problem, we do not have data of the same households passing from adoption to non-adoption. So we only have observational data. That is one point. The second point is households do not adopt single strategies. They often go for a portfolio, so that needs to be incorporated. And the third point is we really wanted to look at not just income, but even the risk aspect for it. So we need an approach that is flexible to us to that kind of extension. Now, the specific objectives that we have looked at with these slides which show the application of MESR are basically what factors differentiate farmers in the choice of risk management strategies. Also, farmers who go for joint adoption, are they better off than their counterparts who do not go for joint adoption of multiple risk management strategies? And again, we follow the same. We collect results from every stage of the MESR and then proceed to derive the average treatment effects. I have got the results on the latest slides, but just before we go there, a little bit about how the data has been adapted to this. The MESR basically looks at the certain independent variables. However, it is possible to include the same independent variable in both stages. So if it is a thought that the household characteristics, individual characteristics will simultaneously impact income as well as the adoption decisions, they can be incorporated. But just so that the equation are identified in the first stage, it is necessary to identify instruments which will work in the first stage but not in the second stage. These should be variables that basically influence the adoption decision but have no impact whatsoever on the income of the farming households. Socioeconomic status and information sources are very common instruments which are used in these type of studies. For the purpose of this paper, we identify and use two instruments. The first is formal training in agriculture, because we hypothesize that households which have had access to formal training would be more inclined to go for risk management compared to the ones who are not able to recognize the benefits of risk management. And the net asset position, because again, we theorize that net asset position is something which would enable households to be better able to go for risk management. Now, the data that we have used and the data which is compatible to MESR is basically cross-section. So this model is applicable in a cross-section setting, and it is applicable at a disaggregate level. So it works well at the disaggregate level. And the reason for this is that when the treatment effects are interpreted, you should be able to say something about the unit which is adopting the treatment without aggregating it. So that is why it works very well with disaggregated data such as household level and cross-section data. In this example, we have used the data from NSSO, the situation assessment survey conducted in 2011 and 13. And from here, we have basically extracted our dependent as well as independent variables. So we have got different groups, demographic characteristics such as caste, age, gender, institutional factors such as access to credit, information, minimum support prices, farm characteristics, as well as risk indicators. So these risk indicators basically have been constructed by combining a data set of rainfall and temperature. So we take the gridded data on daily minimum and maximum temperature and precipitation, and we bring it to district level estimates by assigning each weather station to the district whose centroid is nearest to it, and then averaging the variables recorded at all weather stations assigned to a certain district. And from here, we derive averages for temperature as well as rainfall, and we derive deviations over the long-term trend. These deviations are further bifurcated into negative and positive variables. Now, after this is done, we combine these two data sets, and right before we start with the MESR. The MESR basically is starting from a point where it's talking about having different categories of adopters. And for that, it is very much necessary to have well-defined subcategories. And we do that in this paper by having three groups. So we go for risk mitigation, risk transfer, and risk coping. And the way these are bifurcated is looking at how these categories allow farming households to mitigate, to deal with risk. Risk mitigation are those strategies which are taken prior to the occurrence of a risky event, while risk transfer are basically techniques which allow these households to transfer the risk away from themselves to another party for a fee or premium, such as insurance. And the third one are those techniques which allow households to deal with risk once the event has occurred. So based on the way these strategies function, we have three well-defined categories: mitigation, transfer, and coping. And this screen basically presents a flow chart of how this has been extracted and constructed from the data. So the NSSO data has information of households and which of these are adopting certain strategies. So the first column over here presents these individual, adoption, whether or not they have horticulture crop, whether or not they are engaged in non-farm business, ownership of livestock, and the rest of them. And based on how they allow risk management to occur. We have grouped them into risk mitigation, transfer, and coping. And their combinations are presented in the third column. So the second and third column are basically our exclusive subsamples, which would be incorporated into the MESR. And just before I go to the results of the MES, it's really interesting to look at how the data looks. So this is basically a chart of how the households are adopting these strategies, and it really gives a lot of credibility to even applying this approach, because as we can see over here, households are adopting a lot of these strategies, and many of the households are simultaneously adopting. So it kind of indicates, even before we estimate and apply this approach, it kind of indicates that we need to incorporate the fact that households are adopting not one, but multiple strategies to mitigate and reduce the negative impact of risk. And again, the same chart is replicated, but this time it is replicated for the well-defined subsamples. So there are 8 categories over here, including those households which do not have any risk. And we find that close to 85% of the farm households do adopt some kind of risk management strategy. Risk transfer is something which is observed to be very low. So very few households adopt risk transfer, but risk mitigation is something which is adopted by many farming households. And combinations, again, are adopted by many households. For example, a large number of households adopting a combination of risk mitigation as well as risk coping. So this is a view of the results from the first stage, and this is basically, this is the result from the logic model. The base category over here is those farming households that do not adopt any risk strategy. And from here, we can essentially see which of these included independent variables is basically compelling farming households to go for risk mitigation, and which is not. From this state, we find several very interesting observations. For example, we find that climate risk is something that does compel farming households to go for risk mitigation strategy. We find that those households who have irrigation are less inclined to go, and we also find many of the demographic and institutional characteristics are really very important in these adoption decisions. And moving on to the second stage, this is basically a view of what results from the second stage look. We have 8 separate categories, including those households who are non-adopting. And that is why we have 8 equations which are estimated for these different subsamples. And this stage also incorporates the selectivity terms and sees the impact of adoption on the income. We find that many of the included demographic institutional characteristics are important. We also find that adoption decision does impact in farming income in a very significant way. The results also show that selectivity correction terms are significant, and this results really highlights the fact that ignoring the fact that the adoption of treatment, in other words, adoption of risk management strategies, can be governed by selectivity or can be influenced by observed or unobserved characteristics, would lead to estimates which would be inconsistent, which would be biased, which would not be truly representative. So our selectivity terms are really significant, and this is a result that is consistent across all categories. Lending a lot of credibility towards adopting the whole MESR approach. And the final set of results is basically the treatment effect. So this study basically is looking at, to answer the question, what is the benefit conferred by adoption of these strategies? And this screen is highlighting that in percentage terms. So this graph is basically showing what is the percent improvement in income that farming households saw after they adopted the certain strategies. We have got basically all these categories are listed here, starting from risk mitigation, transfer, coping, all the way to the last portfolio, which is a combination of mitigation, transfer, and coping. It's very interesting to note that mitigation is the strategy which confers the largest benefit, which is 24%. However, the adoption of a combination of strategies or alternatively portfolios gives more benefit than adoption of a single strategy. So farming households which basically diverted their income from other productive activities towards risk management were able to see a lot of benefit from investing in these management practices. Those who went for combinations basically got the highest return, and mitigation and transfer is the one which gives a benefit of almost 41%. This same result has been replicated for alternate dependent variables. So this result is basically coming from looking at farm income, but we have also in this study derived the moments of farm income, which is basically deriving the residuals and raising them to second and third power and interpreting it as the variance and skewness or downside risk. And the same process has been repeated for variance and skewness, and the results or the average treatment effects are presented over here. So this is the benefit in terms of variance that farm households saw after they adopted these different strategies. And we find that all strategies confer benefit in terms of reducing variance. However, the divergence is lesser than compared to income. So in income, we saw that the lowest return was around 11% and the highest was around 40%. Here we see that the highest is around 20%, while the lowest is around 10%. So the divergence here is not as high as income, but even then all strategies do confer benefits. And an important point is that this result is represented as variance reduction. I have presented it in positive terms just for visual ease, just for ease of understanding. Otherwise, these are all negative terms showing a reduction in variance. The same result is replicated for the third moment of farm income or downside risk. And again, it is very much evident that adoption of any strategy would lead to a reduction in downside risk. The highest would be around 16% for the most complex portfolio, that is risk mitigation, transfer, and coping. So the highlight of these three slides, or the average treatment effects for all three dependent variables, is basically that, and this really is a question that we started out with, that do households which go for joint adoption, do they see more benefits compared to households which go for individual strategies? So our results kind of highlight that households which adopt more complex portfolios also end up seeing more benefit compared to their counterparts who go for single risk management tools. After the results, we also conduct two tests, so robustness tests, just to see that our instruments that we have used are suitable. And the way we do it is to estimate two equations. The first is an OLS, the second is a multinomial logit. And what we are looking for is to see that these instruments are significant in the logit equation, meaning that they do influence the adoption decision, but do not have much impact on basically the dependent variable in the second stage, which is farm income. So we find that the two instruments do not really impact the farm income, but have a significant impact on most of the strategies in multinomial logic. Another test that we do conduct is basically exogeneity of the instruments. Again, we found that we cannot reject the null hypothesis that the instruments are not suitable for this study. And this is basically a highlight of how we interpret our results. And I have already covered them, but I'll very quickly summarize them. We find joint adoption is really more beneficial. We find that all risk management strategies do confer benefits. So all of them are positive, not only in terms of income, but also reducing downside risk, but portfolios still confer the highest benefits. From our first stage, we also find that access to information and institutional credit are really very fruitful in guiding farming households towards adopting risk management. And this really is something which can be looked into in further studies. And these results can basically guide farmers to take informed decision in terms of what would confer to them the largest benefit in reducing risk and improving income. So that was the last of my slide of showing the application of the multinomial endogenous switching regression. Thank you very much for listening.
So, thank you. Thank you, Javeri, for a very nice lecture. I think many of the participants, actually, we have just started with the basic techniques, but all of them are postgraduate, PhDs, and assistant professors. So they would have appreciated the advanced techniques, how like they are modified and used on publicly available data, and how this NSSO data can be used to publish high quality papers. So really, I find like it is a very informative session. So I would request Dr. Anju to give vote of thanks on behalf of
any question, clarification?
Questions, yes, some questions if it is there. Them, you can see QA, they want your email ID also. So I can share that email ID, no issue regarding that with participant. And in chat box, so everyone is saying it is an excellent talk, amazing talk. So they want, some of them want like PPTs also. So it is really wonderful presentation, real application like you have given. And you have shown how the analytical techniques are helpful in publishing good papers. Sir, as such, there are not questions. If you would like to add something, sir, that will be good. There are no questions. So, Anju. Mrs. Anju, are you here?
I think there is one question, so I'll just take a minute to
yes.
Answer it. So somebody is asking, can it be used with
nudging experiments?
With index scale as dependent variable. So, really to apply this, just before we go into the estimation, we need to be clear, because we have got dependent variables in two stages. The first is where we are basically looking at the treatment effect. There definitely you can have where, in rudimentary terms, we can say as a step variable, because you would be generating different subsamples by looking at who is adopting which strategy. So there you're going to have something which will go into your multinomial logit model. So, like a step variable. But the second stage where you're looking at the impact on your observed variable, there what would be working for you is a continuous variable. Okay, something like income, something like productivity, because in the first stage you already have taken a variable which is either binary or it is a step variable. So the second stage you would be looking at a continuous variable. I hope that answers your question.
Questions in Q&A also. You can just look at that.
Can it be used with nudging experiments? I'm really not sure what the nudging experiments mean. So.
If you can explain, Ritambra, what you want to know?
Chauhanji, just allow him to talk. Allow her to talk. Ritambra Singh. Actually, some are attending this as a attendee, so they can only post. But if it is possible, let us see. Nudging experiments. Ritambra Singh.
What is nudging?
Yeah, thank you so much, sir. Good afternoon. This was such a wonderful talk. Sir, just in behavioral sciences, for example, if I'm talking about some experiment, like there's a control and there's a treatment, let's say it's all about the burning of all those crop residues. So I want to change the behavior of people, and I want to make them aware what to do with the crop residues. And then I want to share, so I did that exercise itself is known as nudging, when we want to see if there is any behavioral change or not. And we do that with the help of some treatment exercises. In those events, is it possible, like, to assess what will be the impact of that nudging exercise on the ultimate behavior of the farmers that would have led to an increase in some kind of, like, dependent variable could be, sometimes it could be income, sometimes it could be.
So,
So that thing.
if I understand correctly, what you're referring to as the ultimate behavior, that is what you need to quantify. What is the change in behavior that you're looking to, quantify by the application of this, this technique?
Right. So this could be in credit exercises also. So one of the problems is how to utilize the credit. And then credit ultimately leads to, the general theory says, if you are utilizing that well, it could have an impact on the production aspects, productivity aspects as well. But most of the time there is diversion of credit. If a nudging exercise is done, that may have an impact on the utilization of credit. And then what will be the impact? So just, I was wondering if in those kinds of exercises it can be used, but you are right, we need to quantify them and see.
Surely it can be applied to any kind of situations. If you want to change the behavior, you cannot change the behavior, but you can demonstrate the people. If you change your behavior, then this is the likely impact. Say, for example, in case of burning of residues, you said. So what will be impact on their health?
Right, sir.
Something.
Yeah.
What will be the health? How you can then what will be your dependent variables? How you are going to get information on that dependent variables? It may be, say, expenditure on health.
Right, sir.
Okay.
Right, sir.
So it may be expenditure on health, or say the air pollution in terms of the different measures of air pollution are there. So what will be its impact? So it's possible to, likewise in credit also it is possible. In credit, what is happening is there. Then again, the problem is that most of the studies, they use the time series data, to assess the impact of credit on, say, agricultural productivity or something like that. But in that situation, what happens? There is you require a lot of data, time series data you require, and then you have to treat that kind of exercise as a simultaneous equation modeling. First you predict this will be the credit supply, predicted credit supply, and then you see what will be its impact on output supply, input demand, and all those kind of functions. There are two major problems, of course, in the credit. One is credit is fungible, as you said. So it can be diverted to any kind of use, and because unless the uses are specified, it's really very difficult. If there is a long-term credit, then its use is already defined in terms of, it is for construction of the wells or tube wells or buying the machinery. It is there. But in case of, say, short-term credit loans, the farmer may use the credit to buy fertilizer or pesticides and all. Then it becomes really very difficult. So then what is the way out? It is the credit uses are not specified. It is the short-term crop loan.
Right.
So what? So then what you do is that short-term credit loan versus the long-term credit loans, long-term credit, and then you can say, we have done this exercise and submitted the paper, this one, but this is possible in case of cross-section data also. But here again, what happens is the credit agency, they may target specific groups, maybe the scheduled tribe or scheduled caste or OBCs or the women or some self-help groups like that. Or the farmers or the household, they may self-select to benefit from such credit programs. So that's kind of selection bias. And this approach, it helps to overcome the selection bias as well as the problem of fungibility of credit. So it's possible you can apply this technique to any kind of situations, provided you have your dependent variables or the outcome variables well defined. So that is not difficult.
Okay, sir. Thank you so much.
Somebody, okay. Kirti wants to know that can it be applied if the data is taken after some time intervals? So the way this equation is specified as of now is really not accounting for intervals. So the data that it is looking, the way it is treating data is that you have observations at a single point of time. And within that, you are looking at who is adopting, who is not adopting, and constructing your counterfactual. So it is in no way accounting for this time lapse or intervals.
What he mean to say, Javeria, it is, a panel structure.
Yes. So it is not, this is not a panel model. This is not, it's a cross-section model.
Okay, two more questions are there. Somebody says we need to know the steps in the analysis.
So he was not present in the lecture.
And like maybe Suresh, you can see the recorded lecture again, even if you were not there. So that will be helpful. Then there is another question which says, can it be used with index and scale variable as a dependent variable?
So it's really very much similar to what we were just talking. To Ritambra's question, the dependent variable, just before you start it, you have to think about it. This is a very flexible approach. You can literally apply it across many different scenarios, but you need to think about what the dependent variables are going to look like, because you have got two sets. So the first should be the treatment, which would very simply, it would be a binary or a step variable. Either of them would work. And the second should be something like a continuous variable. Okay, so just it can be applied in many cases, but you just need to think about what your variables are going to look like.
Okay. So thank you, sir. So would you like to, sir, add something?
No, that's all. I hope that people will use this approach, and if there is any problem in using it, so you can contact Dr. Javeria or me. We shall be able to help you.
There is, I think, one, okay, this has been answered, I think, Kirti's question. If the data is taken after some intervals, this has been done. So, okay, sir, thank you very much. Thank you very much for being present here and solving some of the problems and questions of the participants. And all of them have liked it very much, because this is a very useful technique for using primary data, especially household level data. So thanks once again, Dr. Birthal and Dr. Javeri, for delivering this wonderful talk. If some more questions or some more things are there, we'll certainly be back to you. And if I have your permission, I can share your email with them so that they can approach to you for this.
No problem.
Okay, sir. Thanks. Thank you very much once again. Thank you. So now we have another speaker, Dr. Sushil Sarkar. Has he joined, Dilip?
Dr. Ken Singh, ma'am.
Okay. And Dr. K.N. Singh. Yes. So he has joined?
Yes, ma'am.
Okay.
Good afternoon, Dr. Rajni. I am very much here.
Okay, sir.
But I think they had very hectic session. If you can have break for 5 minutes for them, that will be okay. Or as you wish.
Okay, we give them 5 minutes break. Okay. Thank you.
नमस्कार डॉक्टर बिरथल जी, ये नई टेक्नोलॉजी से आपके दर्शन हो गए सर हमें?
अब दर्शन करना ही नहीं चाहते हैं।
काम नहीं, हमें पता रहता आप बैठे रहते हो।
दर्शन तो तभी होंगे जब दर्शन करना चाहेंगे।
हम मन से दर्शन करते हैं सर आपका।
अच्छा,
और क्या, ऐसे दर्शन करने का मजा नहीं है ना।
ओके, थैंक यू।
और सर सुनाए?
बस ठीक है डॉक्टर साहब।
कोरोना ने तो थोड़ा दर्शन वर्शन और भी कम करवा दिया है ना।
हाँ, बस मैं तो आता हूँ ऑफिस में, जब अपने रूम में जाता हूँ सीधा, फिर वहीं से वापस निकल लेता हूँ।
सभी ऐसा कर रहे हैं सर,
क्योंकि
तो मैं भी नहीं निकलती।
एज नहीं रही वो।
अरे
और
आप एज बना रखे हो, अदरवाइज आपकी एज तो कुछ ज्यादा है नहीं।
भाई, एज बनाना नहीं बनाना हेल्थ पे भी तो डिपेंड करता है ना। है, आज के टाइम में अगर किसी को कुछ नहीं हो वो भी हो जाता है।
सही, 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 सही। बढ़िया सर। इसमें तो काफी पार्टिसिपेंट्स हैं सर आप वाले प्रोग्राम में। तो
आप मजा लीजिए इनका, अच्छा लेक्चर दीजिए।
अब वो तो देने के बाद ही पता चलेगा सर।
ये क्या रख रखा है आपने? टिफिन रख रखा है या?
हाँ सर।
टिफिन रख रखा है क्या आपने बगल में? चाय के ऊपर, या चाय की केतली है?
नहीं वो हाँ केटली के पानी के लिए रखा हुआ जग रखा है सर ने।
अच्छा अच्छा अच्छा।
मैं एक्चुअली अपने चेयर पे नहीं बैठा, कंप्यूटर से ही दे रहा हूँ। वहाँ क्या है कि वी डोंट हैव द वाईफाई गुड फैसिलिटीज।
ओके ओके,
उसमें क्या होता है बीच में ब्रेक हो जाता है,
चलिए।
तो वो दिक्कत होता है, फिर उसे मजा नहीं आता बातचीत करने का ना, इसलिए कर रखा है। आपका खेल कूद तो सब बंद होगा सर लगता है,
मतलब
मतलब स्पोर्ट्स एक्टिविटीज वगैरह
कहाँ पर?
कहीं पे भी?
अरे आप तो यहाँ कैंपस में रहते हैं, आपके लिए क्या खेल कूद? यहाँ तो
नहीं,
वैसे ही
हम तो अपना चालू रखे हैं।
वैसे ही आप तो वैसे ही कूदते रहते हो।
आप कोई काम तो है नहीं सर। आप लोग कोई काम दिए नहीं।
हाँ। भाई देखिए, अब न तो हम इस उम्र में काम दे सकते हैं और न आप इस उम्र में काम ले सकते हैं।
कर सकते, सही कहा। मतलब इतना सही कॉन्सेप्ट होना चाहिए लोगों का सर। बहुत ज्यादा इरेटिक वेदर रहा सर इस साल, इस पे क्या कमेंट करेंगे आप लोग?
कमेंट क्या करेंगे? क्लाइमेट इज चेंजिंग लाइक एनीथिंग। इस साल क्या, पिछले साल भी ऐसे ही था। पिछले साल
लेक्चर ही उस पे था ना।
है
इसका इनका
हाँ
हाँ,
मैंने
सबका
सही
लेक्चर
पकड़ा।
पिछले साल आपने देखा होगा, जो कोविड के टाइम में जब से मोदी जी ने थाली बजवाई थी, उसके बाद देखो कितने भूकंप आए थे।
सही का बहुत आए थे उसमें।
और काफी आंधियां और ये तूफान वगैरह काफी आए थे। तो वही सिचुएशन अब है, अभी काफी इरेटिक है। एक दिन गर्म हो जाता है, अगले दिन फिर से ठंडक हो जाती है। तो ये जो है, हम नेचर से खिलवाड़ कर रहे हैं ना।
कर चुके हैं रादर मेरे ख्याल से।
हैं, कर रहे हैं, फिर भी कर रहे हैं, फिर भी
हाँ,
नहीं सुधरते हैं।
अब क्या बड़े लोग हैं, अपना पीटेंगे भी तब भी कुछ नहीं होता सर ना, तो क्या कर सकते हैं।
ये तो हर एक की रिस्पॉन्सिबिलिटी है डॉक्टर साहब, चाहे बड़ा हो छोटा हो।
सर आप तो सोशल साइंस हमसे ज्यादा जानते हैं, लेकिन हमारा थोड़ा सा आपसे डिफरेंट है। क्या है कि रिस्पॉन्सिबिलिटी सबके है, सबके सहयोग से होना चाहिए, बट कुछ लोग ज्यादा ही करते हैं।
रजनी, ये कुछ लोगों ने प्रेजेंटेशन मांगी है।
जी सर।
प्रेजेंटेशन तो नहीं, पर पेपर शेयर कर दीजिए इनके साथ।
यस सर, पेपर मुझे जावेरी ने 2 रीडिंग मटेरियल दिया है। वो हम करेंगे।
जावेरी नहीं है, जावेरिया।
जावेरिया।
मैं भी पहले गलत प्रोनाउंस करता था उसके नाम को।
ठीक है, हाँ जावेरिया।
जवेरिया, जवेरिया, जा भी नहीं, जवेरिया।
जावेरिया।
अच्छा, पिछला लेक्चर सर का ही था क्या?
सर का ही था ना?
मैं तो बैठा था सुनने के लिए, बच्चे से
नहीं,
था,
वो सर का ही था, उसके साथ था वो काम। तो उसने मैथमेटिकल टेक्निक उसने बताई थी, बाकी इश्यूज सर ने बताई थी। तो नाउ वी कैन स्टार्ट डॉक्टर के.एन. सिंह।
हाँ, स्टार्ट कर सकते हैं।
हाँ हाँ। सो बिकॉज now I think they would have had enough of refreshment. As such, also we are starting late only, 11:30 only we start. And then they have in between 1.5 hour break. So now, friends, I would just briefly like to introduce Dr. K.N. Singh. So he is a PhD in agriculture statistics from ICR, Indian Agricultural Statistics Research Institute, and presently he is working as head in the division of agriculture forecasting and systems modeling. He has done very good work in forecasting of agriculture production and yield, and he is going to show us some mathematical methods for that. So I would like to request Dr. K.N. Singh to please present your work for the benefit of our participants. And for your benefit, I would just like to tell you that this is very sought after training. Participants like to learn new techniques. All of them have expectations of having exposure to new analytical techniques which they can use in their research. And the group is heterogeneous in the sense it is mainly social scientists, but some are assistant professors across the country and some are even research scholars also. Nearly 35% research scholars are there. So each one of them is very keen to learn the new techniques. So now I would like to invite you for your lecture, sir. Thank you.
Thank you, Dr. Rajni. Thank you very much.
Sir.
I welcome Dr. Birthal also. I would like to, if he gives some comments for my presentation. Good afternoon, everybody. Actually, I had been assigned to talk on role of artificial intelligence in crop yield forecasting. And since this work we are doing for the India Meteorological Department, what the methodology I am going to tell you or what we are doing is not at the micro level. We are working at the macro level because our methodology is being used for giving the food grain production of the country. I would like to share my screen. Share ho gaya kya, Rajni ji?
Yes, sir.
Yes, your screen is shared.
Okay, thank you. And I am audible also. I am audible also, yes.
Yeah, you are visible also.
I am visible also. Thank you, sir. So basically, what we are doing is we are giving the methodology to yield forecast up to district level. And we are using the time series data of the yield at the district level. And you know very well if we are using only time series data of any series, and if you are not, if you are using any techniques, whether it is artificial intelligence or any machine learning technique or any time series analysis, you are going to get some results. But my understanding is if you are using certain associate variables, say exogenous variables, which are related to those yield or that particular dependent variables, so that model is going to draw certain strength and your forecasting accuracy is going to be increased. So on that basis, what we are using here, because I told you that we are going to give the methodology at the macro level, say district level or say block level, up to block level, and data available up to district or block level is only weather variables, say minimum temperature, maximum temperature or whatever variables is available only with the India Meteorological Department is up to district level. So here what we are going to use, we are having yield, we are having the yield of the district for different years, and correspondingly we are having the information about the meteorological variables. And this work is going since 30-40 years because we are having a Fasal project is, is with the Ministry of Agriculture. So using that projects, they are giving the forecast value of food grain production of country. So you may be very well knowing that we are giving the first forecast, second forecast, third forecast, and fourth forecast. And we are using 3 techniques to give these forecasts. One is statistical model, which ISRI has given. Other one is economic growth models. Some Delhi universities, Delhi School of Economics, they are using. Another is crop simulation model, that new center, that is National Center of Crop Forecasting. They are using the crop simulation model using these different remote sensing techniques. And why I am going to use this artificial intelligence, because earlier we are using only statistical models. And any statistical model, or stochastics model, or non-deterministic model, there are certain restrictions on those models. So for example, your errors should be homogeneous, or errors should have some predefined the distribution. But in nowadays, because of lot of advancement, these restrictions can be avoided using this machine learning techniques or artificial intelligence. So that's why nowadays it is more pertinent. You may be seeing that most of the people are using machine learning techniques for developing different models. So ISRI is also very leading institute in developing models using machine learning techniques. So that will come in my lecture. What is the contribution of ISRI? I would like to tell you from very beginning that we are going to use the weather variables, because weather variables plays very important role in the crop yield productions. So actually, initially, Hendrick and Skoll has given a method. They have used the weather variables in the quadratic form, and they have given even Fisher was also involved in developing that model. So they have used the quadratic model to forecast the crop yields. So at ISRI, we had modified this model, and we have given this simple regression model. And the beauty of this model is this generation of these artificial weather indices variables, that is ZIJ. I have explained what is the ZIJs are there. So this is the model we have prescribed for the forecast of crop yield. That is the Y is the yield and A0 is the constant. This ZIJ are artificially generated variables, and these are the regression coefficient. This is the trend for the technology, and this is the error. Generally, what we assume that this error should be homogeneous and normally distributed with mean 0 and sigma square. That is a very strong assumptions for using statistical models. But in real condition, these assumptions may not be true. So in those cases, there are other statistical methods, or the machine learning techniques are going to be used there. So I would like to explain what are the ZIJ. ZIJ are the weather indices, and these are the actually values RIW, XIW, these are the things are there. So, if there are, you can imagine that if you are having P number of weather variables, say 4 number of weather variables, so you are going to generate at least 32 independent variables in the form of ZIJ. And you see, there are suppose 20 years data, 25 years data, or 30 years data you are having. So to estimate all these parameters, the dimensionality problem is going to come. So that's why it is not easy to estimate all these regression coefficients. So that's why there are different techniques to estimate these regression coefficients. These are the values. It is defined that RIW is the correlation coefficient of yield with ith weather variable in WF period. WF period means WF standard meteorological week, because you can partition the whole year in 52 standard meteorological weeks. Say 1st January to 7th January, first statistical meteorological week, then 8th to 14th. In this way, you are having the 52 standard meteorological week. So this is the for WF standard meteorological week, that is the RIW is there. Similarly, RI-W is the correlation coefficient of yield with product of ith and ith I dash weather variable in WF period. M is the period of forecast. Means up to what period, at what statistical meteorological week you are going to give the forecast of that particular yield. That is the M. P is the number of weather variable. And we have assumed error is the normally distributed with 0 and sigma square, means error is homogeneous. So under these conditions, Dr. Ranjana Agrawal, before me, she was heading this division, she has given that because the dimensionality problem was there, so she has prescribed that you should go for stepwise regression to estimate these regression coefficient. So she has given this stepwise regression. You may be very well knowing that what is the stepwise regression. We are having two types of stepwise regression, forward and backward selection. So in stepwise regression, we retain only those independent variables which have significant effect on the dependent variables, say yield. Why we are reducing the variable size? Because it is very important to reduce the number of variables because of certain reason. Reason is your forecast accuracy will be more there and your sensitivity of model will become very high because degree of freedom and other things are going to come in the concepts. So this method was adopted by this India Meteorological Department for the forecasting of district-wise yield of country. Later on, we thought this lasso least absolute shrinkage and selection operator may be better option. So this is also a regression techniques and it reduces the number of predictors in regression model and identify important predictors, just like stepwise regression. But beauty of this lasso techniques or random forest techniques is that here we have assumed that the errors are homogeneous. Here, I mean, this is the machine learning techniques. Actually, my definition of machine learning techniques and artificial intelligence is synonymous because machine learning techniques are what in terms of statistics is nothing but the machine learns the pattern of the data because these models are based on certain patterns. So actually, when we are using any statistical model, say ERIMA model or GARCH model or ARCH model, we are using certain stochastic model. But in machine learning, the machine itself learns the pattern. Although that learn the pattern with certain equations only, but I mean, machine automatically be with its capability and capacity, the machine learn the pattern, and that pattern will be has been very well utilized to, I mean, give into the model. So lasso technique is that technique. So this we have used this lasso technique with in the regression setup, and we found that the performance of lasso technique was most of the cases better than stepwise regression. So nowadays IMD is following this lasso techniques as well also. So later on, there is another techniques that is called the random forest model also. So we had applied, I'm not going to give you the theory of these random forest or lasso techniques in detail because these techniques are available. The R modules is written, you can get anywhere these things. So using this random forest, whatever techniques I am using here for the selection of variables only. I'm not, later on we have used this lasso technique, random forest techniques as a regression model also. But here we are utilizing this lasso techniques and random forest techniques for the variable selections. So this is also a techniques for variable selection, and this lasso techniques, whatever techniques we are using, certainly we are going to minimize the variance. So this quantity we are minimizing, and there is a terms lambda, and we have to see that lambda should be the maximum. If lambda is maximum, then the shrinkage will be maximum, and you are going to get the better results. So these are things. And in the random forest case, we are minimizing this out of bag, and this, I mean, this function we are going to minimize this function. And here we have used some form of trees are made in the random forest, and we have used 2000 trees with 30 runs to build random forest. And what I was mentioning that there was a dimensionality problem in the selection of variables. This Bayesian, we have used this Bayesian regression model. This is not a machine learning technique. This is the stochastic process. The beauty of this Bayesian regression model is, it takes care of your if the errors are heterogeneous also, if the number of parameters are more than number of observations, in both cases, this Bayesian regression can be utilized. And the Bayesian estimation can be understood. This is simply a regression model. And these are the regression coefficients. And what is the added advantage with the Bayesian approach, that we should have some prior information of these parameters. We can assume that these regression coefficients follow
ఇంపాక్ట్ అసెస్మెంట్ స్టడీస్ ఎందుకు చేస్తారు అని మామూలుగా
certain distribution. Say beta follows certain distribution. Suppose normal distribution follows with, these are the mean and variances. And these mean and variances are known because this is the prior information. Then we can go for the posterior distribution. And using this posterior distribution, we have the estimate of these beta 1, beta 2, and whatever beta k are coming. And we have found the performance of this Bayesian estimation using different data also. And in certain cases, this Bayesian approach is also performing better than traditional regression model. And there are different time series approaches also. The ARIMA, simple ARIMA is there, you can apply. Or since ARIMA was not performing good there, so we have tried for the multivariate approach. This is not exactly multivariate. What we have done, that we have selected the independent variable using lasso techniques. And suppose 2 or 3 variables are entering into the model. So those 2-3 variables has been used for the Aremax model, where those variables selected with the lasso techniques has been utilized as the exogenous variable in the ARIMA models. So we have given the term of multivariate approach, but this may not be exactly multivariate, because here we are considering only one error. So this is, ARIMA with certain exogenous variables. And this is the form of ARIMA model. And this is the Aremax model. And these are the certain specification of Aremax model. And this is result of the one of the center. Actually, I will show you that we have developed the automatic this analysis system also, which is running on certain server web-wise, that will later show. This is the comparative performance of the models what I have given you. This is from the Buxar district of Assam. This is one of the results. Here you can find, if you are using stepwise regression, this is the associated statistics. And if lasso techniques has been used for the variable selection, and this is the Bayesian estimation, this is the Aremax model, and this is the random forest model. Here in this case, you can see if you are using lasso techniques for the variable selection, actually, you cannot say that lasso is the best among these 5 techniques, because these techniques are data-driven techniques. So we can say for this particular districts, lasso is performing better. So one more thing is there. I will show you the performance of other data set using the online software we have developed. And one more thing is there, that if the errors are heterogeneous, in that case, suppose you want to use certain statistical model, so that there you can go for the Garch model. What Garch model does, that if error is heterogeneous, so we are using this Garch model in the regression framework only. So here only we are going to model the error. So we have modeled the error, and we have modified the estimate values, and this error can be tested with this test, that is the R's Lagrange multiplier test is there. So if the test says that the errors are heterogeneous, instead of going Armax model or other models, you should go for the Garch model. And in one of the data set, we have seen the error was heterogeneous, and there we have seen the performance of Garch using weather indices. And this is a simple regression what I have shown that Dr. Ranjana Agrawal has given. And this Garch, where we have selected the independent variables using the stepwise regression, and the error was modeled there, and the Garch was used with those variables. And this is simple Garch. If you are not using any of the exogenous variable, only the time series data is there. See the differences. If you are not using any exogenous variables, so any of the Garch model or whatever ARIMA model, the performance is very low. And if you are using judiciously the exogenous variable, using artificial intelligence or using any machine learning techniques or any other statistical like stepwise regression, and if you are incorporating those variables in the model, your results are significantly increased. One more things we have used in this study, that this different this machine learning techniques like lasso and random forest. What result I have presented you here, we have used this lasso and this random forest for the variable selections. And after variable selection, we have used those in the regression framework. And I have given the results. Later on, recently we have done, if we are using random forest and this lasso as a regression techniques, we have tried on 4 or 5 data, and we have found that if you are using this techniques, lasso techniques and random forest techniques for the variable selection and using those variables in the regression framework, the result is better than using directly directly in them as a model. So this is the result, and that's all for this my lecture. And the second part is whatever I was mentioning you, we have developed the automatic software there, and that has been launched on the website, and anybody can use that software for their data analysis. And just I will show you how that is working on the internet. Give me a minute. That is the weather indices based automatic yield forecasting. This IP address we have given wiayfs.icr.gov.in. So this software is running on the system, and something we have written about this software also. And directly I am coming to analysis part also. Here you have to choose certain files. If you want to use these techniques, we have to select certain files. And we have given a file here as a sample file here also. Suppose actually what the software you have developed, the data should be in this format. Otherwise, this is not going to work. This data is from 91 to 2016-17. And this is the corresponding yield. This is kg per hectare. And this is the maximum temperature at 20th week. It goes up to say 37th week it is going. And this is minimum, this is a T minimum for, this is the maximum temperature. This is the minimum temperature for corresponding statistical meteorological week. So similarly, we are having rainfall for those statistical meteorological week, and then we are having relative humidity for that. Similarly, you can add other, weather variable, whatever is available there. So this file you can upload there. Suppose I am choose file. So this file I can upload. Okay, I have uploaded. And now we want the file for forecasting the yield. So again, we have to go for, you have to choose file. Again, sample file we have given. This is the, this is the format of the file to be loaded. So here, if you have counted, there are 18 weeks. So we have to give that we are going to forecast after at the 18th week. So we have given the 18th weeks. Now we are submitting. So this server is at ISRI only. ISRI is having very good computational facility. Because it takes time, because to calculate this lasso techniques or Bayesian techniques or random forest technique, this is this take time also. So now if you see the root mean square error or mean absolute percentage error, we have found that lasso based regression has performed the best among these 5 techniques what we have computerized here. And then we can go for the forecast key in subsequent error, what data we have provided, what will be the forecasted yield. See, the lasso has given 4.5% mean absolute percentage. So that is acceptable with the less than 5% is acceptable for, up to district level. And here you can use any of these 5 techniques for the getting forecasting. But I am showing, I will take the lasso techniques, which we had already found that the lasso techniques is giving the best result. So this shows in subsequent error, this 1877 quintal per hectare yield is going to be there in that particular district. And you can get here certain, related statistics also. But here you can, whatever you feel, you can always use, and you can get, if you want to, if you are interested in stepwise regression also, if you click here stepwise regression, I think it will give you the result if you are using stepwise regression for the forecasting rate. And this we have kept on the, this is the sample, example, but I would like to show you. Suppose I am using some data which is there in my computer. I wanted to show you that these machine learning techniques or these statistical techniques are data driven. We are trying to find out the, the optimum model, which particular model is going to perform best among all the models. People are working on that direction, but up till date, we don't say that this model is optimum model for forecast of anything, which is not available worldwide. People are working for that. And some papers are there for admissible model also. This model may be admissible, but certainly all model, whether it is statistical model or machine learning techniques model or artificial intelligence model, till now, we don't have any, paper that shows that this model is going to perform, best among all the models. That we have not found. Just I wanted to, this is the data. Suppose I am using this other districts, Barpeta is a district. जैनी में तुम्हें 5 मिनट फोन करता हूँ, ठीक, मैं एक लेक्चर में हूँ. See here, it is showing the stepwise regression has performed the best. This is showing on the basis of this root mean square error. So my point was giving this, I mean, this was the arbitrary data that these, I mean, techniques are data driven. When you are changing the set of data, your performance of the, I mean, different models are going to be changed. And this we have made. One thing we are again going to, I mean, you can go for the forecast also. It will work. And we are working on that how, I mean, how we can reduce the number of this statistical methodological week for the forecasting, that still we are working on that. And there are many, I mean, data sets are there, I can show you, but I will stop here. I would like your queries more about this methodology and your comments. Thank you very much. Shall I?
Thank you. Thanks a lot. Let us have some questions from the participants. Sir, you can unshare your screen.
Yes, my God.
So I just wish to have one clarification. That is, here for yield prediction, you need only temperature.
No. You can use any number of weather. We have used minimum temperature, maximum temperature, rainfall, relative humidity, and hour of sunshine.
Okay, but the sample data which you showed, that was having only temperature, minimum.
No. I had shown you the minimum temperature, maximum temperature, relative humidity, and rainfall. You had seen four variables.
Okay. Achha. So one can make use of your software by just preparing the data sheet
accordingly.
Accordingly.
The format we have given, because the software will work only on the that pattern only.
Right. True. There has to be some structure for
that structure we have given.
And it can work for any number of weeks.
Yes, that is the beauty of this software. You can go, because we are going to have now, they are going to give us the NDVI's values of different districts. So that we will incorporate.
Okay. So if you give NDVI values also, I mean, you can add any number of
values. I was mentioning hour of sunshine. Or if you are having any other input variables, say fertilizer or whatever, you can incorporate there.
So number of variables also, it will be able to change dynamically in the software, or you would have to host another software for that?
No. Nothing we are going to change. You have to simply add the respective, I mean, methodological variable or whatever variable which is, related with the yield.
Okay. So that is good. And it is mainly for rice.
No. It is for any crop. Actually, on 17 crop people are, because what we have given, this methodology is not only for specific to any crop. This methodology is for any crop, any location. If you have the data, because this data of different methodological parameter is not available at the micro level. No? You except district level. IMD has data for the district level. They don't have data for block level also. That's why I told you that this methodology has been developed for at the macro level, for the planning.
Right.
And the result is, you have seen that our results are not more than 5%. There is not more than 5% deviation.
Right.
And if you are using this economic growth model or other models, there the difference is more than 20%.
Right. Okay. And regarding the source of data, like you are using from IMD or
They are providing the data.
Acha, IMD is providing.
Actually, we are working in the project team. That's a big project that is called the FASL.
Fasal, acha, okay, you are part of Fasal.
We are part of the FASL.
Acha, acha. So in Fasal, this statistical procedures.
ISRI is giving.
Okay, that is handled by you, right? We are in fact having another lecture on yield prediction. Today only we finalized that. So Fasal kind of thing only, but remote sensing, spatial.
I told you that they are following the NCF,
Yes.
National Center of
So that simulation concept also we will brought into the training.
So you can see what is the mean absolute
Difference. Yes,
certainly you are not going to have 4-5%.
Yes. So in fact, this is, I think, very good approach. So basically, Fasal people, they are sharing the data, and then you are predicting.
Yes.
And number of weeks are the crop growing periods, or like the
it is before we start, before germination till you need. Just for example, before harvesting.
Right.
That's why here we have taken 18 week. 18 week is it before
nearly 3 months.
It was the rice data, but data is in the this was the Kharif season crop data, but other as a Rabi season data.
So if I want to predict for 20th week, let's say, for 20 weeks data, then I will make use of 20 weeks. If
20.
I have, okay. So now suppose, let's say I wish to predict using data of 17 weeks, like the same example which you take. Then for all the years, I have to take 17-week data.
17-week data.
I should not use for all other years the whole crop growth data.
No.
Okay.
Because you see, when we are calculating the weather indices, there you are using that M. M was the period of forecast.
Right.
So if you are because all the cumulative effects are going to be there in the weather indices. No? So you have to use M at 17.
Okay. So here, like first we make weather indices and then we use it here. In this.
Actually, the importance, Dr. Rajni, is this: ki earlier, because the IMD has 38 centers, manually they were making the weather indices. Okay. And you see, it's a lot of work there to calculate weather indices. So since that was my idea, that if you are able to computerize these things, so whole work is going to be done automatically. So there is no need to waste time on calculating the weather indices. And now, since everything we have computerized, so IMD people are very happy because they are saving a lot of resources in this. Manually, it is going to take a lot of time, but now using this our system, there it's at the very easy. The chance of error is also, we have minimized for that. So that is the easy. And we use very simple concept. We don't complicate the things because we are interested in the results only.
Right.
And because if the result says ki our performance are better, we don't have any other way to validate it.
Right. So in fact, I think this is a very wonderful lecture. So participants, if some question is there, like you can ask.
Ma'am, I have one question.
Yes, Santosh.
Santosh to pehle yahi tha. Pucho bhai Santosh.
Sir, good afternoon, sir. Nice to listen to you, sir. I work under Kensing, sir, for 4 years when I was in ISRA. Sir, it was very nice lecture, sir. Sir, I have just one clarification. So the indices what you develop, sir, whether they are product of, let us say we have 4 variables, maximum temperature, rainfall, humidity, and sunshine hours. So when you develop the indices Z11, Z12, Z13, like whether they are combination of all the 4 variables, or you are just taking the product indices and the direct indices, like, sir, that one clarification.
No. Actually, if you have seen my third slide, So there it is written Zij. I takes value 0. I mean, it is written there. I takes value so from 1 to that. So it is combination of many variables. No, you read that simply you vary I and J, you will get the answer there. Exactly, if you read that.
Yes, sir. Yes, sir. I got it. Sir. Yes.
It will be combination of, because suppose differently Z. If you are fixing I, so that I is going to be that particular weather variable. So there are others are not going to come. But J is, you have to see what is the J is there.
Yes, sir. Yes.
So
Thank you, sir.
the thing is, sir, can you provide the link of the software? I had given you the web. It is available, no? Okay. You can write wayafs.icr.gov.in.
You just copy paste the URL and copy the URL and paste it in the chat box, sir.
Yes. You just use our sitting
I will type for everyone. WIAY Weather Index
Automated Yield Forecasting System.
Automatic Yield
Forecasting System.
WIAYFS.
.icr.gov.in.
.icr.gov.in. Okay, I think it will be very useful for the participants.
Actually, my point is that it is a techniques I have used for the crop yield forecasting. For the price forecasting, they can think how, see, if you are using only time series data, you are not getting any strength. If you are using any exogenous variables, that you have to think what exogenous variables you are going to use. So use those exogenous variables judiciously using artificial intelligence. Then you can improve your model. So that was idea of this, talk. So that they have to think.
And sir, you can give some references. Maybe if you have given one write-up.
There we have used 4 or 5 references.
Okay. So the references, paper, like I think they are all are in open source, so they can use.
Yeah, they can use that.
They can use those references also. So sir has provided material also. We will share with you, and you can make use of this. So it was a very, crispy and lucid lecture. Style was also good. You have shown the demonstration also. Like to start working on this, they can straight away use the software, and later if they want to modify something or add some variables, that also is allowed in this. There is, I think, one question. It says, I'm having 5 years of disease, weather and yield data. By using all this, can I formulate the disease prediction model? So
yes, Dr. Rajni, I told you
there is a question.
Whatever methodology I have given, I was using dependent variable as yield. I don't know who has asked this question. He can use dependent variable as disease spread.
Yes.
Disease spread or number of insects or whatever. And he can use, this methodology that is going to work.
Yeah. So basically it is time series based modeling using exogenous variables. Yes. So one can
incorporating machine learning techniques.
Right. So any other question? Then there is another question from Dr. Ganga Devi in Q&A. It says, which is the best technique for price forecasting?
Actually, I told you, Dr. Rajni, I am using this. I told you that there is no best term in the forecasting or those things are there.
One has to work with the data.
Yes, it is all are the data driven. Nobody on the earth says that this particular model or this particular technique is the best for either price forecasting or that thing. But certainly,
you have to work and
you have to work with the different patterns.
Right. In fact, there is a term for this. It says a free lunch theorem. People says there is no free lunch theorem that is valid for data analysis.
Right.
One has to work with that domain data, verify it, and then formulate the model for that. So that is there. Mhm.
This is still correct, Dr. Rajni.
Yeah. So if there are no more questions, so I would like to thank you, sir. In case they would like to approach